here technically to introduce Berytech FabLab, which is a digital fabrication laboratory. It's an open access digital fabrication laboratory. So mainly we are a prototyping place where you apply all the digital fabrication tools you just heard of. What is Berytech FabLab? It's an open access digital fabrication fab lab, which by that we mean that it's open for everyone. Anyone can come and use the tools we have in the lab to build their ideas, to convert their ideas into physical functional prototypes. We have various equipment, various computer controlled machines that produce different scale products and in different material. And mainly we are trying to build a great community of designers, makers, artists, entrepreneurs, people who want to produce stuff, who want to build, make it change. We are part of the International Fab Foundation, so we are not alone. We are part, currently we have like 1,200 Fab Lab in the world, and they are spread all over 78 countries and 24 time zones. Mainly it's full of learners, educators, people in the digital manufacturing or digital industry, people in R&D. So whenever, if you have a certain problem that you are stuck at, you need some consultancy from someone and you can't find it in Lebanon, you can go through this community and they can help you. It's an open access like database and community of people. They have a lot of resources, a lot of do-it-yourself steps that can help you reach the prototypes or the products you want. We started, the Fab Lab idea started mainly in MIT, so it was done by Professor Neil Gershenfeld, and his idea was to provide the environment, the skills, and the tools for everyone to produce anywhere in the world things cheaply and give people access to it, from students to entrepreneurs to local businesses. So the idea was, his idea was to build Fab Labs from the first Fab Lab. So he wanted to build the new Fab Labs based that are produced in existing Fab Labs, and by that we produce more stuff cheaply, and the digital fabrication tools will spread all over the world. After that, Mr. Vigyan Ashram started his first Fab Lab outside MIT, and then the idea spread and it became all over the world. Our mission in Berytech FabLab is to innovate, educate, and collaborate. So we believe that everyone has the right to innovate, to create and innovate. We believe that everyone should learn how to convert their ideas into physical functional prototypes to produce them. And we believe in collaboration, so the input from people that are specified in a certain field could always lead to your breakthrough. Advice from people and that have technical skills in a certain field always help you. If you're doing, let's say, a prototype that has an electronics and you are a mechanical engineer, so you know everything about the mechanics, but you are stuck at a certain line of code that would solve your solution, that will solve your problem, then a computer engineer comes and it would be simple for him mainly. Benefits of starting Berytech FabLab. Mainly we are trying to form a connecting hub between all the makers in Lebanon, all the designers, the artists, the entrepreneurs in this ecosystem to create, prototype, and produce new products. We want to mitigate the risks that are usually faced by people going into producing a new product. So by prototyping and by the help of digital fabrication, you can prototype and test your product before going and doing your mold and mass producing in China. So you can design your product, you can test its viability. If you need to change something, you can change it and produce it overnight, and then the new design can be seen by 3D printing, let's say, the next day, and by that you will reach the end where you know that this is my final product, this is the minimal viable product that we can go to market with, and then we go into industrial scale production. We want to strengthen Lebanon's skills and the technological capabilities, and we want to transform the mentality of Lebanese from just being people who are receivers into people who want to make, who want to change. So we want Lebanese people to know that if they have an idea, they can produce it and make it here in Lebanon. Our capabilities in the Fab Lab, mainly we have various tools in our Fab Lab. We have the digital modeling tools that are the software, mainly the digital fabrication tools and an electronics workbench. The digital modeling tools, as Eli said, they are mainly all the software you use for 3D modeling, 2D modeling, electronics design, even Photoshop and stuff. So mainly it's used for 2D design or 3D design. Some software are used for PCB design, which is PCB is a printed circuit board, so for electronics, and we can use it for Photoshop graphic design stuff. The digital fabrication tools we have in the lab, we have 3D printers. Mainly, it's used for fast prototyping, producing your design in a fast and cheap way. We have two different technologies used in the lab. The FDM, which is fused disposition modeling, which mainly the base material is plastic filaments, and it injects the filament, it heats the filament, and it injects it, extrudes it in layers to form the final shape you want. And we have the Ultimakers, up to 30 centimeter in height, and we have the Delta Wasp, which has a volume of 40 by 40 by 70 centimeter. We also have the SLA printer, which is resin based, so it's a high precision, high quality printer, mainly used for in the dental industry, in the jewelry industry, and for producing high precision functional prototypes that can be used directly from the machine. There are various material available in the market used for various applications. We also have a 3D scanner, which we usually use for scanning parts, to prevent us from designing a part that exists from the beginning. We can use it to scan existing parts and 3D print it directly, or CNC machine it. Whenever you have the digital model, you can produce it in various technologies. The CNC machines, we have also various scales of CNC machines. We have the ShopBot, which is mainly a 3-axis CNC machine. And by 3-axis, we mean just X, Y, and Z. And it's a big scale, 2.5 meters by 1.6 meters. And you can produce either any 2D pattern or 3D objects, but not as precise as the KUKA. But you can achieve, you can build, the input that is used for a 3D printer can also be used on a CNC machine to build a mold, to build the same shape, let's say in foam or wood or whatever material that's not metallic. And we have a desktop CNC machine, it's this big, and mainly it's used for various productions, but we use it in the lab for PCB production. We have a laser cutter. It's a 120 watts laser cutter, and the concept of the laser cutter is a 2-axis CNC machine on the X and Y, and the laser cuts through the material guided by the AutoCAD drawing or the vector file that you produced. And the same file that's used here could be used on the CNC machine. It could be used on the vinyl cutter. The vinyl cutter has the same concept, but instead of having a laser, it's a blade. So the shape that you can cut in wood, you can produce it in vinyl to make your logo or sticker, or to make flexible electric circuits. We have a vacuum forming machine, which collaborates with the CNC and the 3D printing. So you use this machine to build molds if you want to produce, let's say, a certain shape, a bunny or anything in chocolate or wax or whatever material that could be poured. We make the design, we digitally model the design on the computer. We then produce it either by using a CNC machine or a 3D printer. We make the shape, which you call it the master. And then we build the mold using the vacuum forming machine on this shape that we want. We remove the shape and we can use the mold to pour in it whatever material we want. We also have power tools that can be used for hand working. We have professional toolbox, and we have an electronics workbench. In the electronics workbench, we have various tools that are used to test your electric circuits. Mainly, we have power generators, oscilloscopes, whatever you need to test your circuit. And we have a lot of inputs, outputs, actuators that are used to build your prototype. We use mainly Arduinos, Raspberry Pis, low-level microcontrollers, and for an advanced level, we go into MyRios for National Instruments. It has a higher processing power. In the PCB design, we have two different technologies that we follow, but we prefer the CNC machining. We have the etching method, which is the traditional method. We use acid for that, which is not advised by the Fab Academy. So we follow the CNC machining. It's just removing by drilling bit the material that we don't want to get the final product, the final mainly PCB. So these are the Arduinos and Raspberry Pis. They are microcontrollers or the brain of a system. So usually we build the system using all the sensors we need, the screens, the outputs, the lights, the pumps, whatever you want. And you program this brain, this microcontroller, to control the machine. As for what we can do from all this technology that I showed you, we can build robotics, mechatronics systems that are based on electronics mainly. We can build PCBs. We can make furniture by using the CNC machine. We can make 3D objects using the CNC machine. We can use the laser cutter for building. The laser cutter is the best machine in the lab. It's used for various applications and various material mainly. So you can make any shape and assemble it, or you can engrave on material, whatever you want. We can 3D print. Building architectural models is done in 3D printing or by laser cutting, or it depends on your preference. We can 3D print objects, random objects. 3D printing is a wide technology. This is vacuum forming, so this is the mold mainly, and this is what you get as a final object. The sheet of plastic is heated and it's formed on the mold. As for how you can how you can be part of the Berytech FabLab, to begin with, let me tell you why you want to be a member of the FabLab, because you will be a part of a community of makers and designers and artists in this country. You can share your knowledge and you can learn from other people, so it's a collaboration of the skills available in this country. You will get access to the latest technologies that we have, and you will have access to educational workshops. So every once in a while we have workshops that teach the software part of design and the application part of this software in the digital industry business. Who can be a member? We have no limitations. Mainly anyone can be a member in the FabLab, no matter what his age, what his background. He doesn't need to have an engineering background. The concept behind the FabLab is that it's a do-it-yourself lab. So if you want to do a job, you come to us, we teach you how to do your job, and you can do it whenever you want. So once you know the method, you can do it. The hard part in digital fabrication is the design part mainly. So once you have the design, you can enhance it as much as you want, and once you know how to apply your design, you can come and use the machine as long as you want to produce anything. There are different membership models in our lab, mainly for individuals and organizations. Individuals, we have 3 different membership types. And for organizations, it's like a case-by-case scenario. So some architecture firms are coming to the lab where they have many people working in the company, but not everyone wants to use the lab every day. So we make deals with these companies. As for the individual memberships, we have 3 levels where you can get access to the 6 capabilities that we have that I just introduced. So the first level of membership is $40 per month, which gives you access to 2 of the capabilities. The $80 per month gives you access to 4 capabilities. And the $120 per month is a full access to the lab, and it gives you access to everything mainly. The membership includes access to the FabLab space, the safety orientation, the training on the machines, machine reservation, access to super workstations along with the software they have, staff guidance, access to a community of makers, and we give discounts on workshops and courses. As for the pricing, the prices are mainly each machine is priced per hour as much as you consume. So 3D printing is $6 per hour, including the material. Vacuum forming is $10 per mold, which is 30 by 25 centimeters. The laser cutting is $20 per hour. CNC machining is $50 per hour, and the vinyl cutter is $10 per 1 meter cut. As for CNC machining and laser cutting, you get your material, or if it's a big scale, you order it to our site and you use it on our site. As for the workshops, technically we are making many workshops teaching 2D softwares, 3D softwares, and integrating them with the digital fabrication tools. So we're teaching, let's say, Rhino with 3D printing, or Rhino with CNC machining, Adobe Photoshop with vinyl cutting. So the software part and the application part. And many are funded by the Kingdom of the Netherlands. That's how we bought our machines. And those guys are our supporters or our partners. Who follow us on Facebook, Instagram to stay updated about us. And this is our website. All the information you found here is on our website.